Hey everybody, this is Miss Eisencraft, and I'm here with the mid-unit assessment review video tutorial. So let's get going. The key was around the room. It's also there's a PDF version of the key in your Canvas most teachers put it in Canvas. But if not, this can kind of help you understand some things that were maybe a little confusing. So number one, suppose you're working on some geometry problems and you're confused about vocab. What strategies or resources? How about your glossary in the back of the book? Also, a good place is every lesson, there is a summary, lesson summaries at the end of each lesson. Lesson summaries. They have really good notes there. All right, next one. Consider the concept of a regular hexagon. Someone says a regular hexagon is a six-sided shape where everything is even. This isn't specific enough. What does that mean? All right, so a six-sided polygon six equal sides and six, let's say congruent, six congruent sides and six congruent angles. Oh boy, I'm trying to go fast. Congruent, this is a symbol for congruent. All right. All right, consider the diagram below. We went over this in class, but in case you weren't in class. All right, consider the diagram. There are two circles, one centered at A and one centered at point B. Explain why we can be sure that the two circles are congruent. Well, they both share radius AB. They both share radius A. Okay, then identify all line segments that are congruent to BC. So what we're looking for is, first of all, let's look for all radii of the circle centered at B. Okay, so it looks like AB is another radius of this circle. But all the radii over here will work because we already know they're congruent, the two circles. So all the radii over here will also be equal. So we know AB. Now let's focus on this circle. GA. It doesn't matter if you say GA or AG and AD. AH is not quite to the edge. Explain why segment AB must be congruent. So we're looking at this one here. Let me do why AB must be congruent to DA. AB, DA, these two right here. Well, they're both radii of the same circle. So both radii of circle centered at A. Okay. Explain why segments B, C, and DA are congruent. Well, how can I know that radii of different circles are congruent? I think the easiest way to say that, well, there's a couple ways. You could say they are both radii of congruent circles. And we knew they were congruent if we go back to step A. Let's say circles that shared the same radius, circles that shared a common radius. All right, good times. All right, let's keep on going. All right, so then of course I marked up all this. Let me get a new copy real quick. Okay, so let's go right here. Number 4. Suppose your classmate starts with this diagram on the left, and then she uses compass and straight edge construction to get the diagram on the right. So she started with just this. So this construction is a construction that should be familiar to us. Your classmate's goal in this construction was to construct this line CD, this end result. So that's what they were going after, was this. Okay. So what is special about CD? Well, it's a perpendicular line that passes through point P. Okay. It is a perpendicular line. going to use a symbol for perpendicular. That passes through the given point. Point P. Sound good? All right, I love it. All right. In the final diagram, what is the measure of APD, angle APD? How many degrees is that? Well, it appears as though they did a perpendicular bisector, so that makes a 90-degree angle, a right angle, so 90 degrees. Yeah. Oh my gosh, I'm so sorry. All right, carefully write out the steps. All right, there's a lot. So what did this person do to get from here to here? So let me zoom out. This is a lot of writing. Number one, they had to make a circle. They had to get points A and B on there. So let's make a circle centered at P. Make a circle centered at point P. Okay. Then mark intersections of circle and given line, the line that was already there. Label those A and B. Okay. Then, after they had 2 points, doink, doink, make a circle centered at A with radius AB. And make a circle centered at B with radius AB. Okay, so now you have 2 new circles. These 2 bigger ones. Okay, mark the intersections. Mark the intersections. Mark the intersections of circles from step 3. Let's just say that. Label C and D. Okay? Draw a line through C and D. Voila. Okay, keep on going. All right, next we have number 5. Zoom back in. Okay, so this is just wants you to sketch, so I don't want you to freak out that I'm freehanding because it is just a sketch. It says consider angle KLM. Suppose there is a ray LQ that is the angle bisector. So I'm just going to sketch an angle. It doesn't vary or like say how big it is or anything. Okay, so if it's angle KLM, I'm just going to put a point K, point L. It doesn't matter where they are, right? Well, if you name an angle, the vertex point has to go in the middle. Okay, KLM. Now, if there was a ray LQ, ray is just a starts from an endpoint and goes on forever this way. That bisected, I'm just eyeballing it, okay? Because I'm not constructing. I'm just talking about if it was constructed. Okay. If this was an angle bisector, what would be true? So let's read it. Is ray LQ perpendicular to segment LM? This does not make a 90-degree angle. No. Is ray LQ parallel to LM? No, it intersects right there. Is angle, now when you read the angles, the order that you read it actually creates the angle. Is angle MLQ congruent to KLQ? Yes, if it's a bisector, then yes, you've made 2 congruent angles. Okay, so this is a yes. And is angle MLQ and KLM congruent. No, KLM is talking about the big one. And if this was a bisector, this would be half. So this is no. So it's only this one. All right. Suppose one of your classmates follows the steps below. So I'm going to go ahead and do that real quickly. Okay, start with a circle whose center is called point P. I have some room down here. Should we go? Let's do it. We're like making a construction under pressure. Oh no! Told you. To identify the point, you can always, like, if your compass starts dancing, you can remove it. Okay, P, 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 P. All right, mark any point on the circle and label it Q. Boop, boop, boop. Construct a circle with center Q and radius PQ. Let's see what's happening. Stop dancing. Okay. Did it. Construct a circle with center Q and radius PQ. I already did it. Okay. Step 4. Label the two intersection points. What? Of the circles as S and T. Boop, boop. S, T. Construct line ST. Come on, Miss Eisencraft, you can do it. Okay. Now, label the intersection of line ST and segment PQ. I never made the segment, but I can do that now. Segment Q. Okay. And then we're going U. All right. What would be true? Well, it seems like we just made a perpendicular bisector of the segment PQ. All right, so let's see what happens. Is segment PS congruent to QP? What do you guys think? Is segment PS congruent? Yes, they are both radii of the same circle. So PQ is radius of the circle on the left, and so is, QP and PS. Both radii of same circle, yes. Both radii of same circle. Voila. Doo, 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 doo. Is segment TQ congruent to UP? Well, UP is just half a radius. No. Should we explain? Let's just say. Is segment UP congruent to QU? Yes, because the perpendicular bisector of a segment makes a midpoint at that segment, and a midpoint makes, two equal segments. So yes, U is a midpoint. And is ST congruent to QP? Is ST congruent to QP? I'm going to say a big fat no. And why? Is ST, well, QP is the radius and ST is not the radius. All right, good times. We're on number 7 now. Oh, number 7's a doozy, I think. All right, consider the diagram below. How are we doing? Let's go. Okay. Identify all the segments that are congruent to DF. Okay, so DF is the radius of the little guy, right? So the radii of the little guy, we'd say DC and DA. DC, DA. Identify all the segments that are congruent to BC. So BC is the radius of the mid-sized circle, right? BC, so that's AC. And then people noticed EF is also it is the distance from that little circle to the outer circle, middle circle, the inner circle to the outer circle. Okay. All right. Let's keep going. Consider the following statements. What must be true is FA, that's not even a radius, equal to DC, no, is AB, that's a diameter, equal to 4 of the DFs. Well, if I swing this DF around here, whoa, like a little arm of a clock, okay, it looks like it's a radii, another radii, and then we would need 2 more. Yes. How about is CB equal to 3 of the FDs? Yes, if you kind of swing this around here, is, oh, no, just kidding. Is CB is actually only equal to 2 of the FDs. 3, we would need this area right here. So CB is not equal to 3 of these. It is actually only equal to 2 of them. We would need to come all the way over here. So for this one, is AC less than EF? Well, we can't be sure. No. All right. Carefully explain why we can be sure that DE, this length here, DE, the long length, let's make this in green. This is a fun one. DE is equal to 3 ADs. DE is equal to 3 of the ADs. Well, if you look right here, if you swung this around here, if you swung E, like swung it around town, had it come down here, this right here is 1 AD, right? It's equal to 1 AD. It's a radius on the other side. And then here are 2 more ADs. So D to E is the radius of the big circle, and so is D to B. And D to B, you can see, is equal to 1, 2, 3 ADs. I'm going to say, look at the blue drawing. Look at blue label. It's a way to get out of it. Okay. All right. I'll have another video with constructions. Meow.